Have you ever wondered why certain substances are attracted to a magnet while others are not? Let's delve into the fascinating world of magnetism. You see, not all materials are created equal when it comes to their magnetic properties. Take brass and lead, for instance. Neither of these metals are attracted to magnets. That's because they're not ferromagnetic materials, meaning they don't have the ability to become magnetized. On the flip side, we have steel. Steel is a ferromagnetic material, which means it's attracted to magnets. This happens because its molecules align in a specific pattern that creates a magnetic field. It's kind of like how a group of people standing in a line can create a path for others to follow. So when a magnet comes close, the steel molecules line up and follow the magnetic field. And that, my friends, is why the substance that attracts towards a magnet is steel, not brass or lead. Can you identify what is not considered as biomass from these options? Let's take a step back and understand what biomass actually is. Biomass is a renewable energy source that comes from organic materials such as plant and animal matter. It's all around us in the form of wood, crops, algae, and even waste from our homes. Now let's look at our options: rotten vegetables and fruits, dried cow dung, firewood, and tar. All of these, except one, fit into the definition of biomass. Rotten vegetables and fruits, dried cow dung, and firewood are all organic materials, making them sources of biomass. But what about tar? Tar is a thick black liquid that's typically a byproduct of coal, petroleum, or peat processing. It's not organic, nor is it renewable, making it the odd one out. Therefore, tar is not considered as a biomass. What do you think are some examples of renewable energy sources? Now, renewable energy refers to energy from sources that are naturally replenishing, but flow limited. They are virtually inexhaustible in duration, but limited in the amount of energy that is available per unit of time. Let's delve into some examples. Wind, flowing water, and sea waves are all forms of renewable energy. They are constantly replenished by nature and harnessed to generate electricity. Similarly, sunlight, another renewable source, provides us with solar energy. But what about fossil fuels, petroleum oil and coal? These are not renewable. They take millions of years to form and, once used, cannot be replaced within a human lifespan. Geothermal energy, on the other hand, is renewable. It comes from the Earth's core and can be tapped into for heating and electricity. Biomass, too, is renewable, as it is made from organic materials that grow over time. So, wind, flowing water, and sea waves, as well as sun and wind, are examples of renewable energy sources. What practices do you think are not sustainable when it comes to energy use? Sustainability is the key to our planet's future, and this extends to how we use energy. Sustainable energy use implies making conscious decisions to reduce wastage and maximize efficiency. Consider these 4 options: switching off unnecessary bulbs, using renewable energy sources, frequently opening the refrigerator door, and using solar thermal cookers. The first 2 are clearly sustainable practices. Turning off lights when they're not in use saves energy, while using renewable energy sources reduces our reliance on finite, polluting fossil fuels. Using solar thermal cookers is another sustainable practice. It harnesses the sun's energy, a renewable resource, to cook food without emitting harmful greenhouse gases. But what about frequently opening the refrigerator door? This practice is actually energy inefficient. Every time the fridge door is opened, cold air escapes, and the appliance has to work harder to lower the temperature again, using more electricity in the process. Therefore, frequently opening the refrigerator door is not a correct example for sustainable use of energy sources. Do you know the basic characteristics of microorganisms? These minute life forms hold a world of fascinating traits. Let's break them down. Firstly, microorganisms are indeed invisible to the naked eye when taken individually. They're so tiny that you would need a microscope to see these microscopic marvels in detail. Secondly, while it's true that some microorganisms cause diseases, it's a misconception that all of them do. Many microorganisms are actually beneficial and essential to life as we know it. They play crucial roles in processes like decomposition and fermentation, and even in our own digestive systems. Thirdly, not all microorganisms grow in water. While many thrive in moist environments, others prefer dry or extreme conditions. Lastly, Microorganisms have diverse methods of movement. Some use flagella or cilia, while others simply drift with the current of their environment. So, microorganisms are invisible to the naked eye when taken individually, but not all cause diseases or grow in water, and they do not all locomote in various ways. Do you know the characteristics of magnets? This question might seem simple, but there's more to it than meets the eye. Let's delve deeper, shall we? Firstly, you might have heard that the magnetic power is evenly spread all over a magnet. This, however, is not entirely accurate. The magnetic field is strongest at the poles and weakest at the center, so the magnetic power isn't evenly spread throughout the magnet. Now, what about this notion that the north pole of a magnet is indicated by a red color? Well, this is more of a convention than a rule. Magnets don't inherently have colored poles. We humans color them for easier identification. And yes, like poles do indeed repel each other. This is a fundamental characteristic of magnets. Lastly, a small magnet is indeed used in a compass. It aligns with the Earth's magnetic field, pointing to the magnetic north. Therefore, like poles, repelling is a characteristic of magnets, but the magnetic power is not evenly spread all over a magnet. Do you know which activities can lead to hearing loss? It's a question we seldom ask ourselves, but it's vitally important. Our hearing is precious, yet it's often taken for granted. There are countless activities that can harm it, so let's discuss a few. First and foremost, inserting foreign objects into the ear. This can cause physical damage, and it's a surefire way to invite infection. Next up, itching the ear using different objects, which can also lead to physical harm or infection. Overuse of earphones is another common culprit. Listening to music for more than an hour per day at high volumes can lead to noise-induced hearing loss. Now let's talk about safety. Wearing protective equipment when exposed to deep sounds actually helps preserve your hearing. It's an activity that, unlike the others, doesn't contribute to hearing loss, but rather prevents it. So, wearing safety equipment when exposed to deep sounds does not affect the loss of hearing, contrary to the other listed activities.